The next deadly sin of container security is having secrets in the Docker image, or in this case, the Docker file, right? Now, this can be really bad because your secrets, now all of us, when we use applications or when we run applications, will typically be using some kind of secrets, maybe an API key, an encryption key, some passwords, whatever. We have different types of secrets, right? A lot of times developers make this mistake of storing those secret files or secrets as static secrets in the Docker file itself. Now, this, as you can imagine, can be really bad because a Docker file is typically committed to Git repositories, probably is even made public at some point in time. So the secret automatically also gets exposed when that particular secret is in that particular Docker file. So let's have a look at what I'm talking about here, right? So in this case, we have a Docker file, right? Let's look at this Docker file, and you can see that this has a particular secret. It has two secrets, in fact. It has one secret called mypass and the other called encryption key, which is super secret key. Now, when I run this image, now, first of all, it's bad enough that it's available here, right? Now, let us say I commit this Docker file to a Git repository and then, of course, make it available to everyone. That's automatically leads to, that secret getting compromised. The other thing that can potentially happen is when I'm running that particular Docker image. So let's say I'm running -it. I'm going to run this Docker image now. Insecure. In fact, I'm going to use tmux. Let's make use of tmux. It's probably easier to run this. Tmux, and I'm going to split the screen. I'm going to go to the top pane and I'm going to run this particular container, right? Now, when I run this particular container, I'm also loading the secrets as part of the container image. Since it's in the Docker file, the secret's also going to be loaded in the container. So I'm going to run this particular container and I'm going to run it with bin bash. Since it's an Ubuntu container, I know that I can work with bin bash. Now let's go to the lower pane and see what I can do, right? So let's do docker ps and I get a list of running containers. So I'm going to take the insecure container that I just started up and I'm going to copy that container ID, docker inspect. So by using the docker inspect command itself, I would probably get a lot of information about the runtime environment of that container. You can see that a lot of information is now available to me from the docker inspect. So let's actually list that, right? Let's go one after the other. So we have a state, it's called running. It's got the image information, it's got the exec configuration, it's got network bindings, whatever network bindings have been enabled, ports, file system, so on and so forth. But the real important thing is that it also has the secrets that you've loaded in. And if you see the secrets, you can see that it's stored as environment variables, mypass and hello world. Since we loaded the secrets as environment variables in the Docker file, the secrets also take the place of environment variables here, which is mypass is equal to hello world, encryption key is equal to super secret key, or whatever it is. So not only does somebody have access to those secrets in the Docker file, but let's say somebody's running the secrets, or let's say somebody's running the container or running the container on a particular runtime environment, that's when somebody can just do something like a docker inspect and gain access to those secrets. Now, having said this, a lot of folks use environment variables to load secrets on containers or inject secrets into containers. You can do something like this. So for instance, if I say docker run, let me just stop the existing container running and then say docker run -ti -e password is equal to 1234566. Obviously it's a horrible password, but nevertheless we're going to just try and see how this works. So we're going to load an environment variable which is not in our Docker file, mind you. We're going to load this at runtime as an environment variable, and we're going to run insecure again with bin bash. In this case, we're loading a third environment variable called password. Apart from the stuff that we've already loaded in the Docker file, we're loading another environment variable called password, which is set to the value 123456, and we're going to bash into the container. Now, if I change the So let's run a Docker inspect on this. First, let's get Docker PS, get the container ID, Docker inspect, and then we less. Then you will probably see another thing happen when I go to the environment variables section of Docker inspect of the JSON spec that I have. You will probably see something else along with the existing environment variables as well. You'll see that now there is another environment variable loaded in called password, because we did it at runtime. When we were running it, we ran with another environment variable at runtime and loaded that secret into the container as well. So one of the things you have to keep in mind when you're running applications in containers is that a lot of folks would tell you to use environment variables. And in some cases, there's nothing really wrong with that. However, you must remember that if someone has access to your container runtime environment, that someone will be able to see those secrets in the environment variable simply because they can just do a Docker inspector, just pull the runtime specification of that particular container and see what's happening inside the container. Now, ideally speaking, especially because a lot of folks use containers in cloud native environments, I really recommend not using environment variables, but using the IAM to access sensitive variables in Amazon SSM or Secrets Manager or somewhere, or any other container secrets management module. That way you are essentially not loading any sensitive data in the application or in the Docker file or even in the runtime container spec, but the container is using the IAM to pull down all these secrets as in when the application needs these secrets to work. Right, so that I would believe is the best way. However, it's still in many cases there may be requirements where you have to run secrets as environment variables. Even in that case, try and keep it to the minimal possible, simply because environment variables also can be read or can be accessed by someone who has access to this environment. However, in many cases there's no other way out. You might have to still use environment variables. Try and keep it minimal is all I'm trying to say. Especially if you're running in cloud native, I would really recommend you load your secrets from a single source of truth source like SSM or Secrets Manager or some other secrets management tool that your cloud provider provides. So that makes a lot of sense to reduce the attack surface or to reduce the possibility of sensitive information getting compromised. The other deadly sin of running containers from a security standpoint is running bloated containers, right? Now, when I say bloated containers, I mean this. Now, in most cases, you are using containers to run applications. So it could be a Python application or a Node.js application or a ASP.NET application or a Java application or whatever else, right? Now, in most of these cases, you don't really need a full operating system. Uh, right? You don't need a full operating system image or a full operating system container. However, if you look at most of the containers out there, they typically require you to reference a base container like Ubuntu or Debian or Alpine or whatever it is. Now, imagine you're running a single Python binary and you are using Ubuntu 16.04 container image as the base image to run it. Now you can automatically imagine that there is a lot of code in that Ubuntu operating system that is not required at all for your container to run, for your container, to your application to function as intended, right? So in most cases, we end up using these massive images, base images like Ubuntu or Debian or whatever it is, to run these container runtimes, and they're not really necessary. And when you add more code to your container image, the possibility of a security vulnerability creeping into your container image is much more likely than if it was the other way around, right? So imagine you were running an Alpine OS and an Alpine image. The chances of you putting in or introducing a vulnerability over time would be lower than it would be with an Ubuntu OS or something like that. So it really depends on, let us say there is you're running an operating system container Ubuntu, and Ubuntu has this language library or a font library that is vulnerable to some kind of remote code execution, and as a result your application now is also vulnerable to that through some way, right? Now in this case you really don't need that font library or that particular that particular library that is now affected. Now unless you need it, you don't need to add it to your container. However, because you're running Ubuntu by default, you're running all of that code. So running bloated containers is a big problem. Now, Google has tried to solve this in a very big way with distroless containers, and it's really nice. You should have a look at the project distroless. There is also a way of slimming down your existing container images with Docker Slim. So I'm going to just demo Docker Slim. So what this tool essentially does is it essentially slims down or removes unnecessary code from your Docker image, right? So let me just give you an example of what I'm talking about. So let's say Docker images, and I'm going to try and slim down this particular huge image that I have. I have an image called ctf2 underscore zap, which is a 1.75 gig image, right? Obviously, this is based on Ubuntu. It has a bunch of libraries, and some of those libraries are required, but a lot of those libraries are not, right? So since it's running on the Ubuntu operating system image, there's a good chance that you're running a lot of unnecessary code. So if I use Docker Slim to trim it down, Docker Slim essentially inspects the image. It inspects all the different layers of the image, and then of course it tries to reduce the unnecessary code that is there in that particular image. So now it's done, right? So Docker Slim is now done minifying the image. So it essentially what it does that it takes the image and it looks at the application that you're running. It looks at the different types of dependencies that the application needs. It inspects the layers and reduces the unnecessary code. Docker Slim also has multiple modes of working. So you could also use the SecComp and AppArmor profiles. It automatically generates runtime security profiles for you if you need to do that. In this case, all I've done is just use the Docker Slim variant, but if I use SecComp and AppArmor profiles, I can actually even generate SecComp and AppArmor profiles. I have not personally tested those, but that's supposed to be one of the key features of Docker Slim as well. Apart from minifying the images, Docker Slim is also supposed to remove or generate, SecComp and AppArmor profiles for you for your Docker images. So let's look at what this has done. If you look at Docker images, you'll see that it generates a .slim version of the same image, and this slim version of the same image is now at about 555 meg versus the previous 1.75 meg, which was much larger. So you can see that there is a huge difference in the image that you're running now versus the image that you would be running with Docker Slim, right? Now, this is one example. This may not necessarily always affect the security. Just because it's a slim down the image does not necessarily always mean that it affects the security of your application running in the container. Although I would advise you to look at reducing the number of dependencies or the number of layers in your images. Docker Slim can probably help you with that. And in addition, probably look at, let's say you're running a single application, you're running something which is Python or Node.js or Java or something like that. Look at distroless simply because distroless is a specific base image that is built based on you should be looking at distroless simply because distroless is a stripped down operating system that only runs that one application or that one binary that you give it. So let's say you're running a Golang binary, it only runs that with the necessary dependencies, and that's really useful. Another thing that you should consider doing is to use multi-stage builds with Docker, right? One of the cool things with Docker now that you can do is have a image built in a different Docker container, and then the artifacts of that particular image being loaded in a target container where you're actually running the application. So all of the heavy build stuff is happening in this, let's say an Ubuntu or a Debian container where it needs to be built, but only the build application and the build binary is now being loaded into another target container, which is actually going to be running, and that's a much more slimmed down, trim version of the container with less code, and as a result, less security vulnerabilities possibly because you don't really have to have package managers and all of that stuff in there. You're essentially just running the target variant in that particular slimmed version of that container. So you should consider using something like multi-stage builds to be able to reduce the amount of code that you are loading into your container specification. In fact, distroless works on that principle, so you should definitely take a look at distroless. Take a look at Docker Slim and see what it does from that perspective as well. The next deadly sin of running containers from a security perspective is running --net is equal to host. Now, this is something that you've already seen, especially with the --privileged example that I finished up a little while ago. right? However, net host is a little different from the privileged example that I gave. Now, in the net host configuration, if you enable the -net is equal to host flag, what happens is that the Docker container uses the host network. It does not use the isolated overlay network it creates, but it uses the host network to actually run that particular service. So let us say you use -net host and you run a MongoDB database. That MongoDB database is open on the host's port, and anyone can connect into that MongoDB database from that host port. So let us say you have MongoDB or Redis or whatever it is. Now anyone outside of that particular host can access MongoDB or Redis or whatever it is that you're running, even though you're running it on a container. So that you can see is obviously a security issue depending upon how you have configured your services or whether you really want it that way. But this can be a security issue simply because someone can now talk to your service, whatever that service may be, directly on that particular host port, and potentially lead to a compromise of that particular service, because now that service is accessible to outside computers on the network, either publicly or on the local network, depending upon how your host is configured. So let's look at what this means and how this works. So in this case, what I'm going to do is run in daemon mode, and I'm going to run a MongoDB database. In this case, I'm going to use net is equal to host and run Mongo. This is the Mongo image, right? So if I look at Docker PS, you'll see that I'm running that particular Mongo image, and you'll see that there are no ports published simply because I'm running this container as the with the -net is equal to host, which means that whatever ports are published by this, or services are published by this particular container, are now running as a service of that particular host. So there's no real overlay network, there's no isolation. There is this host network that has this particular service published, and anyone can access this, which means that now if an attacker wants to find this service on my host, all the attacker has to do is look for this particular service on my host, and the attacker can potentially use that to leverage whatever he or she wants against my environment. So let us say in this case I'm going to use one of the nmap NSE scripts, which is MongoDB -databases, and I'm going to run that against localhost, and you'll see that since I'm running a non-hardened MongoDB database, I'm able to access all of the database, dump the database, and so on and so forth, right? So the same kind of thing I can do with MongoDB info. I can do the same thing instead of the databases. If I want to get a runtime info of the entire MongoDB setup on there, you can see that I'm running, I'm able to do that with this. So with the net host option, what I'm now doing is I'm running MongoDB as a service that is available on the host. So let's take another perspective. So let us say I'm not doing this. So let's say I'm going to stop my current MongoDB container and run Mongo as just another service. So let us say I'm just running fnd Mongo, and you'll see that I'm still running this. Again, it's not published. Now in this case, I'm not running it with net host, right? Since I'm not running this with the -net is equal to host, this, while this still has a network service, it's not really published to the host, or it's not using the host network configuration. So if I run the same nmap command that I ran a while back, you should see that it's closed, simply because that's not published on the host. Now this is a pretty important concept, especially because a lot of us run a full stack. So let's say I'm running a web server, and then I'm running a bunch of databases, and I'm running some middleware. In that case, what I need to do is, from a simple orchestration perspective, use something like Docker Compose or whatever it is to bring up that particular network. So Docker Compose automatically creates a network that allows all of these different containers to talk to each other. In a more obviously macro perspective, Kubernetes allows you to do the same thing, where you have different deployments and different services, and these services can talk to each other using a service definition. And of course, depending on the way you've set up network policy and so on, you can allow or disallow these services from talking to each other. However, one of the things you should definitely keep in mind is not allow your net host flag to be running when you're running a particular container deployment. seventh and the last deadly sin of container security is running more than one service per container. Now, one of the things that I always like to talk about, especially in my classes or with clients or whatever, is that containers are not operating systems, right? Just because they look like an operating system and talk like an operating system doesn't mean that it's a full operating system. You should not be running a bunch of services. I've seen container setup where you have an Nginx server running, and then there's an application running, and there is some application related services like, let's say, a queue service or a queue server set up under it, and all of this is running as part of a single container, right? Now, obviously, this is terrible from a performance and efficiency standpoint, simply because you have to cram all of these specifications into a single Docker file or whatever and run it. The other thing that it also does is makes it hard to secure, right? The way you would secure an Nginx web server is very different from the way you would secure a MySQL database. So the way you, if you don't run these as independent services, so let us say you run MySQL as a separate container and you run Nginx as a separate container, what you can do is actually secure these services in a much more granular way. You can add specific app armor profiles, add specific SecComp profiles for MySQL databases versus Nginx with a completely separate viewpoint. So that makes things easier to secure because you have a discrete set of services that are doing one thing per container. So let me give you an example of how not to write a container spec. So in this case, it's a very old example of one of ours where you would see something like this. You would see that this is not just running this is running, of course, from a base image of Ubuntu 16.04, but more than that, what is really happening is that you're running an Nginx, you are running a Python Gunicon application server, you're also running a RabbitMQ server. So in the same container image, this is actually really bad practice where you're running an Nginx, you're running a RabbitMQ server, and you're also running the Gunicon and the Python application to support that particular deployment. This is in a single container. Ideally, this should all be separated out. So Nginx running separately, RabbitMQ running separately, and the Python application running as a third container. And of course, you can use Compose or Kubernetes to be able to orchestrate the service between all of these three different containers. Ideally speaking, make sure that you run only one container, one service per container. So that brings me to the end of my video for the week. This was 7 deadly sins of container security. Now, I obviously understand that there may be completely different security risks that you might be thinking about. Obviously, this is not an exhaustive list of container security flaws or sins. It's just some things that I felt were important for you to learn as a basic user of Docker containers or container technology in general. There are a lot more videos I'm planning around container security. Stay tuned. And if you'd like this video, please follow us on Twitter, subscribe to this channel for more videos, and follow along on my blog. Thank you very much.